we're continuing on with our second video with trigonometry and dealing with triangles. Now, up until now, we've been doing right angle triangles, and as I said, you cannot assume that we have a right angle triangle unless there is an explicit square happening in the corner. So moving forward, then the question is, well, if I can't use SOHCAHTOA, what can I do? So that introduces what the first of our possibilities. We're going to be looking at the cosine law in this video. So if you have a triangle like this, not a right angled triangle, called oblique, we have two other options. You have cosine law and sine law. If I took a look at this example here and told you guys to calculate b, obviously we can't use SOHCAHTOA. Now to figure out if we're going to use cosine or sine law, what we have to do is look at the triangle that we have and see what information we're given here. So here I've got a side, an angle, and then another side. So based on that, I can use cosine law because cosine law works if we have either all three sides of a triangle or if we have, like I said, a side, another side, and the angle between them. So side, angle, and side. I have the cosine law written 3 times here, but really it's only one. There's just some things to be aware of. So for any triangle, we can label A, B, and C for our sides with lowercase letters and capital letter A, B, and C for our angles. To use the cosine law, this angle and this side correspond, and then you've got these other two sides in the triangle. Okay, so whatever way you label your triangle, you can pick and choose A, B, and C and solve for whichever side you're looking for, or for whatever angle you need. You might notice if we look at this last one in particular, oh, that's why I changed that. I'm missing a 2. So that should be a squared. Sorry about that. If you take a look at these formulas, in particular the last one, if we covered up this part over here, you're left with Pythagoras. So Pythagoras is really just a special case of the cosine law. So let's go back to that first example that got us started here and give it a try. Looking at this triangle, I see that we have a side and another side and angle between them. So side angle side means that we can use the cosine law. Since we're solving for b, I'll pick the one version of cosine law that has b squared by itself on the left-hand side. So you might have noticed the pattern with all of these different versions of the cosine law. We've got the side that we're interested in and the angle that it corresponds to on the outside kind of edge here. And then all of the rest of the calculations are using the other sides that are in the triangle that are values that we have. Right, so here I'm solving for b. I've got angle b, and then I'm using sides a and c to do the rest of the calculations. I find it helps to have a list of my knowns, what I know about this triangle, so I'm putting in the right values in the right place. So I know that side A is 15. That's the side that's across from angle A. And then I know that C is 20, and my angle B is 124. I can then go ahead and plug those values into the formula. The rest is just a calculation, and be careful going forward with your calculator that you're multiplying the right numbers together and not taking the cosine of whatever this ends up being when you multiply it. So just be careful with that. You may want to do it step by step instead of trying to put it all in one step into your calculator. We also have to be careful. You'll notice when you type in cos of 124 degrees, you do get a negative value. So don't forget, negative times negative is going to give. Also, make sure you're keeping enough decimal places side of an angle. And of course, the last step that we're always going to forget because we've done so many things already, square root both sides. And there's our answer. 30.99 because the question asked for 2 decimals. This next example, again, I've got a side, an angle, and a side, so I know that I have to use the cosine law. This example is exactly the same as the last one, so go ahead, pause the video, give it a try, and then come back to check your answer. And you should get A equals to 33 on that last step. I'm just running into some technical difficulties and I may have to restart my computer here, so sorry about that. Possibly see you in the next video. Maybe this one will keep going. We'll see. All right, crisis averted, we're still here. So 33 is your A value. Looking at this next example, I see that we're given 3 side values. That means, again, we're going to use cosine law. So if you have 3 sides, use the cosine law. We don't have a diagram, but we should draw one because otherwise we won't know which angle we're looking for and making sure everything makes sense. So draw a random triangle. The side lengths are all pretty similar, so we don't have to be too careful there about things being to scale. I can be totally random in how I label them. It doesn't matter which one is 7, 9, or 14, or in this case A, B, or C. But what does matter is that if I made this side my 7, which is A, this here is my angle A that we're going to be looking for. Since I want angle A, I'm going to use this version of the cosine law and go ahead and plug in all of my values that I have. So I hope you can see why it doesn't really matter which sides we drew in our triangle to be B and C, because the order here of these values doesn't really matter, right? Whether I do 9 squared plus 14 squared or 14 squared plus 9 squared, not going to make a difference. What does matter is that this side and this angle are in the right spot in our formulas. So go ahead and crunch those numbers because we'll use some calculators here. So this is going to seem really obvious right now, but be careful that you actually add these numbers and don't mix this number into your addition and subtraction yet. Remember that it's going to be multiplied by cos. Often I see people see that all of these numbers are kind of similar to each other, and okay, adding and subtracting, I can do that really easily with my calculator, and this number gets mixed into this addition and subtraction before it's been multiplied. So just be aware of that. We're done our number crunching. Now all we have to do is a bit of algebra to get to A. So remember, A is stuck with this cosine, and I can't just, divide by A or divide by cos somehow to get rid of it. So what we're going to do, we're going to put it in a box. Okay, and we'll deal with getting cos and A separated later. Let's just try to get this piece by itself first. We'll go ahead and subtract 277 from both sides. And that leaves us with some numbers. Be careful with your negatives. Don't lose track of those or do any funny math there. And we're still trying to get that cos A by itself, but now I've just got some number equals some other number being times by the box that I'm trying to isolate. So we divide both sides by that negative 252. So we figured out that cos of the angle A is this fraction over here, but I still haven't actually figured out A. My last step after this, if I want to get A or any angle out of whatever trig ratio it's attached to, I need to use that inverse function business. So what I would say is that A, the angle value itself, is going to be the inverse cos of that number I had before. And this is why I left it as that fraction without worrying about simplifying it or anything like that, or writing out a decimal here. If I can put this into my calculator, it's going to be far more accurate than if I had calculated this number, gotten a decimal, and made some rounding errors. So whenever possible, try to put this actual calculation into your calculator. If not, copy down the number that would go here with a couple of extra decimals just in case. So that should give you 25.2 degrees. The next example is the exact same thing, so let's review the process of what we did so we know how to do these types of questions. We started out by plugging in the right values in the right spots. That's always really important, so you may want to sketch to do that first. Once we did that, we did some arithmetic in a bit to get that cos A piece by itself. Then the last step, we use our inverse cos function to solve for the angle value. This last example, we've got 3 sides to a triangle, so we know we're going to be using cosine law. But here's where you're going to have to draw a good diagram to figure out which angle am I going to try to solve for, and which one of these is the side that's across from it. So pause the video, draw yourself a sketch, come back and see how it compares to what the answer should be. If your triangle looks like this, you might be running into some problems because it's kind of hard to see which of those angles is going to be the biggest. Notice how all three sides that I've drawn here look about the same length. But in reality, 42 is almost twice as much as these other two sides. Notice how by drawing a diagram that's more to scale, we can now see pretty quickly that this is the biggest angle and that that's the one that we're going to try to solve for. Now all you have to do, pick a couple of letters to be your A, B, and C, totally random and arbitrary. So let's just go A, B, C. Set up that formula, do a little bit of algebra, and then at the end, do the inverse function of the cos to get your angle by itself. Pause the video, do the work, and then see how your answer compares. We've got all of our rearranging done. All that's left is that final inverse cos calculation. So you'll notice here on my calculator, I went ahead and did this number. Rather than write this number down, stay away from your clear button on your calculator. All you have to do now is hit the inverse cos button and it will do that for this number here and keep all those decimal places for you. So we hit our second function, cos. Well, that's embarrassing. All right, so I did negative 559 divided by 1196, and now I'll hit second cosine, and it better work, and there's our angle of 117.9. So that's how we get our angles. That's it for cosine law. Check back for the next video to do the sine law. The algebra is easier, but conceptually there's more stuff going on.